A particle P moves in a straight line such that its displacement, x meters, from a fixed point O at time t seconds is given by x is equal to 2 plus 6t minus 2t cubed. We want to find the distance of P from O when t equals 0. This would also be known as the initial displacement. Actually, it's distance, so the sign won't actually matter. So we just need to calculate x of 0, and we get just 2 if we substitute t equals 0 into this expression. So x of 0 is 2, and that is in meters. We now want the distance of P from O when t equals 2. So what we want is x of 2, the displacement evaluated when t equals 2. So that is going to be 2 plus 6 times 2, which is 12. Take away 2 times 8, 2 cubed being 8, which is 16. So that is 14 take away 16, which is negative 2. So the distance is 2 meters, but it's worth noting that the displacement is negative 2. So what that actually means, if this is the fixed point O, x of 0 would have the particle here, and x of 2 would have the particle here on the other side of the fixed point O. We now want the initial velocity of P. So, to get velocity, we are going to differentiate. The velocity is dx dt. So if we differentiate that, we get 6 take away 6t squared. And so v of 0, the initial velocity, is just going to be 6 meters per second. We now want the acceleration when t equals 1. So to get acceleration, well, that's going to be dv dt. So we need to differentiate the expression for the velocity. And so that is going to be, well, the 6 will disappear. It's going to be negative 12t, and that would be in meters per second squared. And we want a of 1, which is negative 12 meters per second squared. Then we're asked for the time or times at which the velocity is 0. Okay, so let's put v equal to 0. So that means 6 minus 6t squared is equal to 0, because 6 minus 6t squared is the expression for velocity. That gives me 6t squared is equal to 6, so t squared is equal to 1. So t is equal to plus or minus 1. But usually we start at t equals 0, so it is just going to be when t is 1 second. And now we want the distance travelled in the first 3 seconds. Now there's a couple of different ways of doing this. So this is the line along which our particle is travelling, and let's say this is the fixed point O. We know that initially it is at a point which is 2 meters to the right. We also know from here that it's travelling in this direction, and that means that it will continue to travel in this direction until t is equal to 1, which we've just worked out is when the velocity is 0. Now, what happens after that? Well, if we look at the expression for velocity, we can see that when t is more than 1, the velocity will be negative. So in other words, it's going to travel back this way until it reaches some point here when t is equal to 3. So we have the expression for the displacement. X of t was 2 plus 6t minus 2t cubed. We know from before that x of 0 is equal to 2, and I put that on my diagram, which you can see. What about x of 1? Well, that is going to be 2 plus 6 take away 2, giving us 6 meters. So in other words, this one is at 2, this is at 6. So here it will have travelled 4 meters. We also want to know at the end of the time period. So what about x of 3? Well, that's going to be 2 plus 18. Take away, 3 cubed is 27, so it's going to be take away 54. And that is equal to negative 34 meters. So looking back at our number line, we know that it travelled 4 meters here, and at that point from O it was 6 meters. And then at t equals 3, it's over here at negative 34 meters, which means the distance it's travelled back this way is 34 plus 6 is 40. And so the distance travelled in the first 3 seconds is going to be 44 meters. The 4 meters it travelled to the right, and then the 40 meters that it travelled to the left. Now, if you have the calculator available, you can do that with an integral. You can see here how I've got the modulus of the velocity. 6 minus 6 would be t squared, but I used x dx, integrated between our time limits of 0 and 3. And you can see we got the answer 44. This is a technique you can use in methods as well, so it's very useful. The distance is given by integrating between your two times the modulus of the velocity vector dt.